In this video, I just want to quickly revisit quadratic equations. Okay, we already know what the standard form of a quadratic equation looks like. It's ax squared plus bx plus c equals 0. Okay, we were calling that standard form, where I've got the quadratic form on one side and 0 on the other side. A is not 0. A, b, and c are constants. Now, so far, the only constants that we've used for A, B, and C have been real numbers, but I want to tell you this bit of information here, that our quadratic formula and all the reasoning behind it still works if instead of real numbers, we actually allow A, B, and C to be complex numbers of any kind. Okay? This just means A, B, and C are elements of, that means belong to or members of the set of complex numbers. Okay, that's what C stands for, if you remember that notation. Now, the quadratic formula was x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and we found that was true by completing the square. Okay, let's revisit a few problems now here. Okay, now we have complex numbers behind us here. We can actually write solutions to some quadratic equations that we couldn't before. Let's consider here, this first example. X squared plus 4x plus 5 is 0. You can see A is equal to 1, B equals 4, and C equals 5. Okay, those are complex numbers of a simple type. They are real numbers. Remember, every real number is a complex number, so I have not really taken any imaginary numbers yet, but I will. Anyways, so let's come back, consider this simpler situation, and I'm wondering what x is, okay? Okay, so we use the quadratic formula. We just stick in the numbers. So it's negative 4 plus minus the square root of 4 squared minus 4 times 1 times 5 all over 2 times 1. Okay, so that's negative 4 plus minus 16 minus 20 is negative 4. Now, our expression for the square root of negative 4 is what? 2i. So we actually have negative 4 plus minus 2i over 2. Okay, remember that 2 is dividing both of those terms. So I get negative 4 over 2 is negative 2, and 2 over 2 is 1i. Okay, so we've got two solutions, negative 2 plus I and negative 2 minus I. Okay. All right, so before we would have said there's no solution to this because there's no real numbers whose square root is negative 4. Okay, but now with complex numbers, we can give solutions. Let's consider another situation here, just a little bit more complicated. I've got 2x squared plus ix plus 3 equals 0. Notice this time I'm actually using an imaginary number in here, instead of just real numbers all the way through. So A is 2, B is I, and C is what? 3. Okay, let's just stick in the numbers. X is negative 1 plus or minus the square root of I squared minus 4 times 2 times 3. Okay, that's all over 2 times 2. Okay, so that's negative I plus or minus negative 1, right? So I squared is negative 1. Minus 4 times 2 times 3, that's 24. So I'm going negative 1 minus 24 underneath the square root sign. All over 2 times 2 is 4. Okay, so that's negative I plus or minus the square root of negative 25. The square root of negative 25 is what? 5i, right? Because the square root of 25 is 5. So don't forget your I there, because it's actually the square root of negative 25. Okay, so now I've got two solutions here. X is negative I plus 5i over 4, which is really what? 4i over 4, which is I. So one solution is I. And the other solution is negative I minus 5i, which is actually negative 6i over 4, okay, which is negative 3 halves I. So that's the other solution. So we've got these two solutions here. Okay. And let's take one other example here. I'm going to go x squared plus x plus I is equal to 0. Okay, So you can see that A is 1, B is 1, but C is actually I, okay? Now, put in the numbers. X is negative 1 plus or minus the square root of 1 squared minus 4 times 1 times I, all over 2 times 1. So that's negative 1 plus or minus 1 minus 4I over 2. Okay, now here is something that we haven't covered yet, and in fact we're not going to cover in this class, being college algebra. To take the square root of 1 minus 4I, it exists, 1 minus 4I, and it is in fact another complex numbers, okay? But this actually takes some trigonometry, okay? This actually takes some knowledge that's beyond the purview of this course, okay? But I'm going to tell you that the square root of 1 minus 4I does exist, and it turns out to be about, this is only an approximation, 1.6 minus 1.25I, okay? So I've got negative 1 plus or minus 1.6 minus 1.25I, all divided by 2, and then I take the two different situations, plus or minus here, and I get the following. Again, these are just approximately true. I only went to so many decimal places. But 0.3 minus 0.625I, okay? Or here's another solution, negative 1 plus 0.625I, so plus there. Okay, so this equation still has two solutions when you go to the complex numbers here. Okay, alrighty, so there you go. Okay, so I just wanted to inform you that our quadratic formula always works, but in some situations where you've got complex coefficients, you might run into a situation where the knowledge required to actually work out the details is beyond the purview of this course, although a good calculator that can work with complex numbers can compute this easily. Okay, but the understanding, the complete understanding wouldn't be there. Anyways, just wanted to revisit the quadratic equations. You should be able to do any of those now. Okay, I hope you understood this. Bye.